Good morning, and we're going to go ahead and take a brief look at orbital notation. Keep in mind this video tutorial is designed to take a look at after you looked at the PowerPoints, and I realize that orbital notation is something very new. You're seeing some diagrams you've never seen before, so let's take a moment and kind of look at what we should be seeing. You should have seen that new word orbital, and orbital is referring to a place where we think an electron is located. It's probably there. Because at this point, we understand the quantum mechanical model says that electrons are moving so fast in so many different directions that at no point can we know where they exactly are or how fast they are going. And so when we look at orbital notation, understand that this is probability. We're predicting where we think electrons are located. And so once we understand that within an atom, there are different sublevels. Okay, there are different sublevels. There's all these different, it's not just energy level 1, energy level 2. We now understand that within each energy level, we have sublevels. So for example, if you think about Knox County as an atom, within Knox County, you have levels. Okay, you have various cities, and within each city, you have even smaller levels. You have certain neighborhoods and things. And so that's what we kind of have to start to understand with our mind. Think of this diagram that you see here, and as you're going to do some practice also in class, this is an orbital notation diagram. And each one of these spaces is where potentially 2 electrons can go. And we're going to use arrows to represent those electrons. Now, before we get started by putting these electrons into our orbital notation, there are a couple of rules we've got to talk through. And these are also mentioned in the PowerPoint as well. So if you want to go back and kind of look at a more specific definition, you can. The first rule is, or principle, excuse me, is the off-ball principle, and that says that we are going to put electrons in the lowest energy level first. So when we look at this, we see that 1 right there is referencing the first energy level. That 2 is representing the second energy level. But we also see a 2 over here. So what that's telling us is that the second energy level actually has 2 what we're going to call sublevels. As we put electrons into our orbital notation, we're always going to start at the first energy level, and then we fill up the second energy level, and then we fill up the third energy level, and it goes on and on and on. And we'll talk a little bit more about electron configuration and that pattern tomorrow. The Pauli exclusion principle is actually something that I mentioned to you all yesterday, and I'm going to go ahead and kind of give you an example looking right here at that 2p sublevel. Let's say that I have 3 electrons that I need to put in here. 1, 2, 3. I've put 3 electrons into this sublevel, but the question is, remember I said yesterday about hotel rooms? We think of this as though we have 3 hotel rooms. And if we have 3 hotel rooms and 3 people, why would we want to throw everybody into a hotel room together when we could actually take this guy and move him over here? And so that's exactly what we're going to do. The Pauli exclusion principle states that you're going to put 1 electron in each orbital until they're all full. If we were to do this with 4 electrons, it would look like this. 1, 2, 3, everybody's full. Now I come back and put a 4th one in that room or bed or however you want to think of it with the other electron. So that's the Pauli exclusion principle, that we're going to put 1 electron in each bed before we go back and put a second one in there. This last one is Hund's rule, and this has to do with the spin of the electrons. Electrons are magnetic, and they actually move opposite of each other, which means when I'm putting an electron into an orbital, electrons do not spin in the same direction. So that's wrong. They don't spin in the same direction. That's wrong. If you notice up here, electrons always spin in opposite directions, and that's according to Hund's rule. And so what I would like to do now is go ahead and take a look at one. Let's look at nitrogen. Locate where nitrogen is on your periodic table. Give you a little hint, it's in group 17, group 15. It's in group 15. And how many protons does nitrogen have? It has 7. And why am I always trying to identify the number of protons first? Well, because in a neutral atom, I understand that the number of protons and the number of electrons is the same. When we look at this nitrogen atom has 7 electrons. Here we go, which means I'm going to end up with 7 arrows over here in my orbital notation. The off-ball principle says we have to fill in the lowest energy level first. So here we go. 1, 2. I've used 2 electrons. I need to put 7 in there. I have 5 more to go. I used Hund's rule because 1 up, 1 down. Okay, so we've got 5 more to go. 1, 2, 3, 4. Okay, now I have 3 to go. Notice that here's where I'm going next. You're going to work your way up this orbital diagram. It's 4, 5, 6, 7. I've satisfied all my rules. I've spread those electrons out, 1 in each orbital. Nobody's moving in the same direction. I filled the lowest energy level first. And so now when I look at this diagram, I can see that the 1s orbital has 2 electrons, the 2s orbital has 2 electrons, and the 2p sublevel has 3 electrons. Okay. The next thing that we're going to do is take a look at 4 example problems in class.